is not only ecologically critical, but socio-culturally rich. However, it's now facing intensified climate-induced hazards such as landslide, globes, flash floods, and earthquake. Today's discussion will focus on how we can build resilience in these fragile mountain regions through collaboration, technology, indigenous wisdoms, and scientific research. We are truly honored to have with us the domain experts and the distinguished speakers, Dr. Gupinath Bhandari sir and Dr. Ronit Chatterjee sir, who will help us explore actionable solutions for a safer, more suitable future in the Himalayas. If you have any questions or reflections during the sessions, please feel free to note them down. We will take them up at the end during of our brief interactions round. Let us begin this session with a few words from our visionary founders. I now invite Dr. Bishwajit Roy Chaudhuri, the founder, chairman of SAIARD and faculty in the Department of Geography, Vidyasagar College, University of Calcutta, to share his insights and opening thought. Sir, over to you.
Okay, thank you, Goenka, and thank you for to my team, and also the honorable delegate, guest of honors for today's wonderful webinar topic. So, first of all, on behalf of South Asian Institute for Advanced Research and Development, SAIARD, I heartily welcome to all of you, and obviously all the delegates to participants also. So, for conducting this important webinar on such important topic and connecting two of my beloved person, Mr. Ronit as well as Gupinath sir. So they are basically a stalwart in their particularly in disaster risk reduction field, and we are very much happy to hear from both of you. And hopefully, through your presentation, as you know that since the last few years we are continuously doing such kind of knowledge exchange dialogues through our platform, connecting with the different people, those who are expert on that particular field. And today's session will obviously be helpful for those who would like to build their career or who would like to think about some in the field of the disaster risk reduction sector. And they will be definitely be enriched along with us. So I congratulate once again, and I thanks to Goenka, our research associate and the in charge of our North Bengal chapter of SAIARD, for conducting this important webinar on such important topic. And I congratulate to all the participants, those who have joined from the different corners of India to listen. So congratulates once again, and please over to you, Goenka. Thank you.
Thank you so much, sir, for your thoughtful words and inspiring visions. It's now my privilege to welcome our keynote speaker, Dr. Gupinath Bhandari, a respected academic and expert in the field of disaster management. Dr. Bhandari serves as a professor in the Department of Civil Engineering at Jadavpur University, Kolkata, and is the coordinator of the Center for Disaster Preparedness and Management at the same institute. Sir has made significant contributions to disaster risk reduction, resilience planning, and community-based disaster management with both national and international engagements. His research and mentorship has greatly influenced the interdisciplinary field of disaster science in India. We are truly privileged to have him with us today to share his insights. We look forward to your keynote lecture, sir. Sir, what to you? Now, platform is yours.
Thank you very much. But they have prayed too much. Just we are trying to work on this field. Definitely, we have to have a success in this field. But the field is, there is no boundary of this field. That is the main issue. And now another additional point came, which is climate change, which is really non-linear, and there is no trend on that. Only trend is climate is getting changed, but how it is changing, that's why so far probably mathematical model could not be, I mean, developed on this, but everybody is trying. So that too in Himalayan region, uh, that is, in my opinion, that is more difficult. Uh, uh, in coastal belt, something will happen, and in mangrove forest, Sundarban, something will happen, uh, and in the hilly terrain, once again, some other parameter we have to check. Now, when we are thinking about climate change in the hilly terrain, definitely, uh, just a minute. Let me take the, yeah. When we are thinking of the climate change and resilience, um, in hilly terrain, before that, we have to make a plan, appropriate plan for the development. I mean, human settlement or tourism, we have to plan properly, because we have an experience in Joshimot. Joshimot is purely human driven disaster. Whatever happened there is purely human driven disaster. Now we have to think about Gangtok and Darjeeling also. If you fly, I mean, over these two places and take some snap, maybe nowadays we can take it through drone, you will find that a lot of concrete trees are there. No, I mean, natural plants are there, and the buildings are on the slope. That is one major issue. Because at the very beginning of the science, we have studied that the always the force will go towards, I mean, in the direction of gravitational attraction. But here, the buildings are not on the horizontal slope. So some component will come, and the land will try to slide due to that force. I'm not going into the detailed engineering, but as a civil engineering, I mean, I should not stop here. That's why I'm telling this. And what is landslide? Landslide is basically the, I mean, soil mass with heavy load is trying to go down, but the soil friction is there. I mean, that friction is between soil surface and soil surface. If the resistance is not sufficient, then definitely the soil mass will fall down. Our resistance is, if the resistance can be created sufficient, then the slope failure will not occur. But in this case, what example I have taken is basically additional load we have imposed on the ground of the hill terrain, which is not horizontal once again. So now that slope, you have some capacity to carry the load, because everything they do have some capacity. If we put, I mean, more load on that, I mean, beyond the capacity, then definitely failure will come. Now, what is happening there? You can see it is very easily that, I mean, with days, with time, the number of tourists is increasing. Maybe some seasons are there, So everybody is trying to catch maximum tourists. I mean, they are keeping their business in their mind. But the problem is there is a term called optimization. That optimization we have to know, we should know, and the construction should have proper planning. Even the after the construction, I mean this additional load, which is called dead load, because it cannot move. So apart from this additional dead load, some live load will take entry. I mean the tourist who can move. That is called live load. So live load will come because for the tourists only these hotels and I mean guest house etc has been constructed. So when the guest house or this hotel is full of tourists, definitely maximum load is there. And at that point of time, suppose if that sliding occurs, then nobody can resist it. Rather, beyond construction, I mean, before construction, if we take engineering help and design properly the foundation and the superstructure of the building, or even, I mean, the restriction of the landslide, number of structure can be, I mean, constructed. High cost is there also. I mean, low cost solution is also there. I mean, as an Indian, I always, as an engineer, I always try to solve any critical problem or any engineering problem uh, as a low cost solution. In that case, what happens basically. I mean, the client or the authority, they will decide. Yes, we can proceed forward. If the cost becomes more, then definitely the solution is there, but will not go to construct that. Just a minute. Now, another important point is also there. Apart from it, surcharge load, I mean additional load, drainage problem will be there if it is unplanned construction. In a planned construction, definitely drainage facility will be there. But in case of, I mean, unplanned, the drainage facility will not be there because everybody is thinking about his property, his or her property. So drainage is common, so nobody will think on that. One, I mean, event or disaster, which I should say, should mention, though the reason is different, still there is a connection between, I mean, with my discussion. After Nepal earthquake, probably second or third time, because there was three times vibration, uh, probably second or third, huge precipitation was there, maybe whole night and in the morning also. After that, no, so it was second vibration. After that, the rainfall was there, and during third vibration, we have seen landslide in Mirik. Definitely, you can recapitulate this. or you can go through Google also. Date I can't say, I forgot just. But before that, probably in Merik, I mean, in Merik, we don't have any experience of landslide, and Merik is not a landslide prone area also. Then why suddenly landslide occurred there? Because very simple. I mean, during earthquake vibration, some cracks have been developed. Cracks have developed within the hilly terrain rock. But the problem is, if water goes into that place, the water cannot come out. There is no drainage facility. So after the vibration, rock failure was there, then precipitation, then due to pore pressure, the landslide occurred. And this is basically, if you can recall, that in higher secondary physics, everybody of us learned about Pascal's law. Very simple. So, but when we have studied this, we never know, I mean, this can happen. And when it happen, then it should not be complicated. Any problem, if we think in appropriate direction, then definitely we'll get some solution. Thing is that when this kind of disaster occurs, we call, I mean, lot of engineers, maybe initially from the state, then from country, then, I mean, foreign country also. See, thing is that, I mean, all the science students, those who have studied the science, have learned the same science because science is unique. We cannot change. Yes, uh, even by following the science, we can have different kinds of solution by analysis or different kind of test result in the chemical laboratory. That is basically our mistake or our, I mean, crudeness in the work. But I mean, the degree of the solution would be almost same. It may not be equal or equivalent. So every molecule of water will be able to create pressure in all direction, equal pressure in all direction. This part is Pascal's law. Even Pascal's law, if we think about Pascal's law, it will happen. If we do not think about Pascal's law, then also it will happen because it is basic science. So here the importance of the drainage is there. If, I mean, the precipitation water or wastewater, it runs, I mean, surface runoff occurs and it, I mean, go downwards, then we have to take care about, I mean, some structure or something so that it can flow smoothly. But there are also some problem. I mean, when suppose precipitation is coming, so initially the ground may be dried up, So whatever the water will come on this surface will go towards the subsurface through seepage. If the soil is saturated there, then only surface runoff will occur. So the seepage part may create water pressure and surface runoff also. I mean, it may create some surface covering. So negative part is there, but to avoid to eliminate the negative part, we have to work on the basis of science. So we have to resist the seepage, and if we resist the seepage, then definitely the 100% water will fall down through surface runoff. And on the other hand, because of surface runoff, the surface covering will occur. Uh, even I mean, if the slope of the hilly terrain is steeper, then probably surface covering will happen more because the velocity will be more. If the velocity is more, the kinetic energy within water is more, and if the kinetic energy is more, then it can able to do something more, and it can cover the sediment there to keep itself in a with a minimum energy, because in the system every material, every animal, they want to keep themselves in a with a minimum energy. Now, what may happen furthermore due to this drainage failure? I mean, the seepage water can create once again the water pressure, which can create the landslide, and the surface water may also can I mean create the disaster uh, by scouring the surface soil. Sometimes the foundation may get exposed, and this has happened. I mean, maybe in number of times, but in a one project, they have invited me to come down with the slope. I mean, solution. And from Calcutta only, when we are speaking on telephone, I just asked, I mean, was there any rainfall 2 days or 3 days before this? Yes, sir. And what was the intensity? Sir, really I do not know, but it was heavy rainfall. Then I told, without seeing the field, I told that no, it's not landslide, it is basically due to surface covering and to some extent for pressure creation. Because if you follow the sketch or the photograph or really in the field, then definitely you can understand. You'll be able to understand what is failure and what is, I mean, slope failure and what is surface covering. Because in case of surface covering, we'll find that very low depth soil has been eliminated from that place. But in the inside of that slope, I mean, on the opposite end, there may be a room and everything is fine there. So, this thing should also be taken care while designing everything, because here the pipes which are going into the ground, is basically foundation of the building. And n number of buildings on a small area that will create additional load, and anything may happen anytime. Once again, I should say that, like that area we have faced already, this is the major issue. Nowadays, we're thinking to divert this location, so that every places can have, I mean, small intensity of, the tourist or tourist density should be less. But if we put this restriction, then definitely some person will lose their earning value, and some political version will come out that no, it cannot be done. So if we start from that place, that unplanned construction, then surface covering, then landslide, then unplanned construction is once again coming in the explanation, and you will find some dry food required to spend the whole day outside the room. But that is not sufficient, I think, at least not for me. So, this way, if we proceed, then definitely this kind of disaster may happen. Another issue is, though, as on date, the Environment Department or National Green Tribunal, all these boards are really very active, but we are cutting the trees and doing the construction, even by filling up the water body by soil, we are going the huge construction. So there also, I mean, we are we're responsible for this climate change. But climate change is 100% man-made, human-driven, in my opinion. I'm not expert, but I do not know what other expert says. I can give you another example, but that is not on hill, which already been published. Uh, one fellow, she has completed PhD. She could prove that the degradation of mangrove forest in Sundarban is due to climate change. And this degradation once again putting, Kolkata further climate change. So on Calcutta, there are two system systems which are giving the uh, resultant of climate change. One is global climate change, and is local climate change due to Sundarban degradation. So that is proved. The publication was also very high impact journal. I cannot recall it now. But in the hill also it can be proved. I mean, in the hilly terrain, other than normal slope stability, I didn't work too much, but nowadays we are going to start on this. All the issues will be taken care. But I don't know whether we can reach towards the solution or not, because every time these value of these parameters are getting changed, and those are not linear. Those are really very non-linear in property. So I mean, uh, development of mathematical model is really very tough for this. And in most of the cases, even in the simple, I mean, changes, if you have a target to develop mathematical model, then definitely we should have some assumption on the science. But science will not follow this assumption. Then afterwards, we have to cancel it and we have to follow the nature. But it is well accepted in our society, first to assume, then try to develop the final one, and if it is acceptable, it's fine, or else we have to go to further rolling pattern. So this is basically the random climate change, history of the random climate change. And another issue may not be climate resilient, I mean climate due to climate change, but for children, is there any playground in the area? I can say no. But how? I mean, they are constructing the larger area. In that case, they will definitely destroy the forest or the plants, because we will always try to have our property in a safe side. I mean, so-called safe side, though it is not in safe side. So we'll clean it and construct it. This sort of negative, I mean, impact will be there. Another issue is the landslide nowadays is occurring. There is no particular season, because due to climate change, the rainfall is also not systematic. And in some of the year, the precipitation was started on the evening of Dashami or day after Dashami. And at the point of time, I was in north only. And I told that due to the rainfall, this I mean, spot may get closed by landslide. The same thing happened. I should not get satisfied on this. this is not the ultimate solution of this disaster. I mean, the resilience of this disaster. We should always try to flow of the science and never place work against the science. You can definitely work, but it will not be able to give you a good result. Uh, this much, I mean, was in my mind as a civil engineer, but a lot of issues are there. So we should follow the construction rule and construction science so that we don't have any negative impact and at least can have moral study and have some drawing on the issue and can understand everything so that we can push towards the slope. Solution. This is the issue. I don't know. I mean, a lot of things are there to discuss, but uh, this time, I mean, we have discussed this. Just a verbal discussion. I didn't get time to prepare the slide because one of my student, is working on that impact of climate change on landslide. There, we could prove yes, there is a role of climate change on this landslide. So, this kind of question you can definitely raise, and definitely it can come to your mind, and you can raise it.
Okay, thank you. Sir, sorry to interrupt you.
Uh,
Sir, may I respectfully request to conclude your lecture as we
yes,
are
yes,
running behind.
I'm going towards that only.
Okay, okay.
Uh, Now, you can share my mail ID with them so that they can raise their question through mail. I mean, to the participant, I'm saying.
Okay, okay.
Larika,
Okay, sir. Okay, sir.
yeah, you can
Okay.
share my email ID so that they can throw their question through email ID and definitely I'll give the answer.
Okay, sir. Okay, okay. Thank you. Thank you, sir. Thank you so much for sharing your practical insights drawn from years of work on your ground. And thank you so much, sir. Now we come to the next session of webinar of our expert talk. It's give me great joy to introduce Dr. Ronit Chatterjee, a dynamic thought leader in the area of environmental resilience and disaster risk innovations. Dr. Chatterjee is the co-founder and CEO of RIKA India, a renowned organization working towards disaster risk governance and sustainable development solutions. He is also holds an academic positions as a visiting associate professor of Keio University, Japan. Hello, uh, Sir Gupinath, sir. Sir, are you there? Okay, okay. Okay, Dr. Chatterjee continued to contribute his dedications to international research and collaboration. With his vast field experience and deep understanding of risk systems and international frameworks, Dr. Chatterjee brings a global perspective to local challenges. We look forward to learning from his valuable experience. Today, Dr. Chatterjee will be speaking on very relevant topic, which is building resilience of Indian Himalayas against cascading hazard risk. Sir, over to you. Now you can share your insightful thought with us.
Thank you, Goirika, and thank you, Vishwajit and SAIARD, for the invitation. It's a pleasure to be here and talking to all of you. Um, Let me just share my screen. I hope it will
Okay,
be
sir.
visible soon to you. Can you see the screen?
Yes, sir.
Okay, great. So I'll be talking on the Indian Himalayas, as this session is, we are focusing on the mountains, and I think the Indian Himalayas is the more, I think if you look into the current situation, it's the Himalayas which is having a lot of flooding issues, flash floods, and landslides going on. So I think it's quite apt that we are talking about the Indian Himalayas now. And as you can see, what I'm going to focus is more on the cascading hazard risk. Why it is so? I think Professor Bhandari also briefly touched upon this. Like there could be floods, there could be landslides, but still, when we are making plans, when we are approaching risk assessment, the problem is we are considering single hazard and its impact, not considering the cascading or compounding or the systemic nature of the risk. Okay, so I'll try to briefly introduce you to this topic of cascading risk. And if you are interested to know more, I would be very happy to get in touch with you later on if you have queries, or you can, and I also share a paper that we have recently done. So coming to Indian Himalayas, I'm very sure that all of you are aware of the Indian Himalayas. We possibly now are facing a lot of issues in the Western Himalayas, where Himachal and Uttarakhand is there. And also, I think there has been reported cases now also from the Eastern Himalayas. Central Himalaya is mostly in Nepal. So, but there also there has been recently an earthquake, tremors felt, there has been flooding issues. So the whole of Himalaya actually is now facing issues. But the Indian part has recently, like last week, it was I think in Himachal, there were a lot of flash floods and flooding and then landslides, and now we are seeing the same thing happening in Uttarakhand. But it is just not limited to floods, earthquake, landslides. There are also reported cases of forest fire, drought, epidemics, of course, and lightning, cyclones, and so on. So there has been various kind of, the hazard profile of Himalaya is very varied. But what we possibly do not do is linking all these different hazards and seeing that how one can trigger the other. And that's where the complexity lies. Because when we have just one hazard, it's possibly easier to manage because we are targeting your resources to manage one hazard, and then looking at what kind of mitigation measures should be there, what kind of relief should be there, who are those population who could be affected. But when it comes to cascading impacts, many times it happens that the cascading impacts generally fall beyond the scenario, the general scenario creations, because it might also get triggered in certain areas which were not affected earlier. So that's where it becomes very important to identify how this cascading impact would happen in especially hilly terrains, because that's where especially the Indian Himalayas are very young-fold mountains. So it's quite fragile. The ecosystem is fragile, but preserving it, conserving it also is of importance. So when you look into the mountain ecosystem, this is from a very recent paper. You can look into this. So basically, you have people, you have livelihoods linked to the ecosystem services, you have food, health, well-being, and so on. And all of these, when a hazard event happen, has direct impacts. Say, for example, precipitation change or increasing in wildfire, and that is again linked to the change in the climate. Uh, then we also have indirect impacts, which are generally not looked into so much. Like, say, for example, I was working in Kalimpong, and when I was there, I People were, when I was interviewing people, they said that, this area earlier used to have grasses which were quite tall, like around 3 feet, up to 3 feet in height. But now this grass sizes have reduced. Uh, the There used to be pigeons. The pigeons used to be found around 2,000 feet from the ground. But now you cannot find any pigeons around 2,000 feet. It would be possibly you can find them around 2,500, 3,000 feet. So it has gone up. Earlier, Kalimpong used to be a very known for oranges, but now you cannot grow oranges in this area because the moment you start growing oranges, there is insect um, infestation which is happening, and that would actually wipe out the whole orange orchards. So what is happening is there has been a lot of change, and it's just not impacting say oranges or pigeons, but also impacting how building blocks are being made, what kind of equipments are being put. Like earlier in the hills, there used to be no issues of flies or mosquitoes, or people used to not use fans. But now the whole, because of the temperature changing, people have started using fans, air conditioners. Now there are issues of flies, mosquitoes. So it has actually have a lot of implications, indirect implications, which we possibly are not taking into account. So I'm trying to give you some risk of what cascading risk looks like. Say, for example, glacial melting and globs, glacial outburst lake, is interlinked. So glacial melting would lead to globs. So climate change, and it's possibly known that climate change is going to accelerate glacial retreats. Melting of glacial retreats will unstabilize the glacial lakes, and this would lead to breaching. And this is something which has also happened recently in Sikkim. And it has been seen that along the Himalayas, this has been happening for now almost 10 years, 15 years, and this is quite a recurrent phenomenon. The second one is heavy monsoon rains and landslides. This is very common in the eastern Himalayas, like in the eastern part of India, where we have Kalimpong, Darjeeling, Sikkim. So this is a very common. The moment you have heavy rain, there would be landslides, triggering landslides. And these landslides are not just triggered because of the heavy rain, because it's years of various other factors adding to it. The rainfall becomes the trigger event for triggering the landslide. Then earthquake and landslides, again, this is a very common cause and effect relation. Many of the earthquakes have triggered landslides in the past. Deforestation and soil erosion. So deforestation has been happening in the hills. There had been, after that, till 1984, there has been a lot of deforestation happening in the Indian Himalayas. Suddenly, there was a realization by the forest department, and then the forest department tried to see that how do we again put a green cover on the Himalayas, hills and mountains. So, what the suggestion, what was the way to do it, because the green cover needed to be done very fast. So what was done is, instead of looking into what kind of earlier species were there, a lot of plantation of pine happened. And then what you see now, those pine forests have become a big issue for landslide in the hills. So it is just not deforestation and afforestation, but also that the impact of that is now felt in landslides, which again relates it back to earthquakes and landslides in point 3. And again, then climate change, ecological disruption. So the ecosystem disruptions are happening. I don't know if you are aware that the Western Ghats, which is starting from Maharashtra, Karnataka, and all the way up to Kerala, is a UNESCO World Heritage Site. And one of the factor why it is a UNESCO World Heritage Site is because it actually the biodiversity and the of that area impacts the microclimatic conditions. So when you disrupt the whole ecological system there, it also has a possibility to impact the microclimate of that region, which would again then have and would lead to certain kind of hazards getting triggered. So this is how the cascading risk looks like. I'll possibly try to also elaborate it through another example in the next slide. But before that, what is more important is for you to understand that what is the difference between a single hazard, all hazard, multi-hazard, and top hazard. These are the 4 ways of classifying hazards and how we are approaching to understand them. The single hazard is we take one hazard at a time. Like, okay, we take earthquake, flood as standalone events. They don't do anything beyond just getting triggered. All hazards approach is where we consider all possible hazards that can happen. Like, there can be many hazards. Now, multi-hazard approach possibly is a subset of all hazards approach, where we are considering that multiple hazards can happen, and this is where the cascading hazard will get linked to. And then we have top hazards. Like, say for example, if we take all hazard, and I'll later on tell you why it is very difficult to actually have an all hazards approach. It will actually go into an infinite loop if you go into risk assessment. So, but these are the 4 different approaches which can be taken. So that's where we possibly now look into this top hazard approach, where we say that, okay, we know that there can be 20 different hazards, but what we are targeting is the top 5, which has possibly those criteria can be defined, that either we are selecting those as the most recurrent one, or we are selecting them because the number of casualties were high. So that contextualization can be different based on why we want to take those hazards. But these are the 4 different kind of approaches that we can take. Now, coming to cascading hazard, which is again part of this multi-hazard or all hazard approach, you can look into this. Like, you have one primary cause, okay, which can lead to a specific hazard, like a hazard event, and then it would have an effect. Say, for example, you have floods, and flood led to washing away of lot of houses. Now, there could be another issue. You had floods, which led to washing away of lot of houses and warehouses. Now, these warehouses were having chemicals. So when water gets, reacts, certain type of chemicals also react with water, and they create fire or explosions. So there could be a secondary hazard created here that might have a totally different kind of an effect. So like that, there could be so many different scenarios which could be created. And that's where it is very important to understand how one hazard and the other hazard is interlinked. Then this is again from a paper that we did recently. When we are looking at systemic risk, cascading risk, and compounding risk, then there are certain characteristic features that are common to them. One is the multi-hazard profile and the vulnerability scenario. So if you don't have multi-hazard profile, there would be no case of cascading or compounding or systemic risk. Second is the interconnectedness between systems, because if the systems are not interlinked, then one to the other will not flow. So the systems basically are actually the ones which are kind of passing it over to another system. The non-linear causal cause and effect chain relationship, underlying risk drivers, which is again linked to the vulnerabilities, and the tipping points. So the thresholds or the tipping points where it could get triggered. So these are the common factors which we need to consider when we are considering cascading, systemic, or compounding risk. I'll just give you a quick example of how this cascading risk can be taken into, and this is from a tool that I have developed for United Nations Office for Disaster Risk Reduction, UNDRR, where we were trying to see, can we have a multi-hazard approach assessment or a quick risk estimation tool developed for the MSMEs. So there, what we try to do, because we are doing a global tool, which will be used across the globe, it's very difficult to have a very generalized approach for such kind of tool development. But and at the same time, it has to be logical, and there has to be a scientific background to it, and people also should need to understand and would be easy to use. So what we did first is, how do we zero down on the different hazards? So we took up various continents. Then what were the last 30 years most top hazards in terms of their occurrence? So that's how we figured out these hazards. Okay, and we took the EMDAT source. Then what we tried to do is use the risk function, which is a function of hazard, exposure, vulnerability, and then create a scenario of H1, which will have a consequence livelihood, impacts direct or indirect, dominoes effect on H2, which is a hazard 2. So hazard 1 triggering hazard 2, and that's where you see the cascading impact, which might again go back to in the loop to impacts and indirect impacts, which again then flows into dominoes effect and H3. So like that, we can create cascading impacts and then take into consideration while designing the tool. So if you see here, what we are trying to do is we are taking a location-based approach where we say that, okay, location of MSME has, or MSME is micro, small, medium scale enterprises, would have hazard 1 and hazard 2. It's a multi-hazard scenario where hazard 1 has likelihood and severity, and hazard 2 also has likelihood and severity. Now this is displayed as H1C1, which could be a case. H1C2 could be another case. Similarly, H2 would have H2C1, H2C2, and then they would again have likelihood severity. So what we can do is basically primary hazard, secondary hazard triggering, and secondary hazard and the tertiary hazard getting triggered. So it could lead to something like this of a matrix, where we possibly need to take 1, 2, 3, 4, up to 4 such cases, and then we need to stop it, because or else it will, as I said, it will go into a loop which we cannot close. So we possibly have to put a kind of a limit to it. So if you are interested to know more about this is a recent paper that we have done on unpacking systemic, cascading, and compounding risk based on cases that we have seen in Asia Pacific. So it would give you a much better understanding of these concepts and how you apply it in the mountainous regions of India and elsewhere. Thank you, and I'll be very happy to answer any of your questions.
Okay, thank you. Thank you so much, sir. Thank you for your enlightful presentation, and also your sharing your insights with us. And we now open the floor for a short interaction session. If anyone has question or would like to respond to the speaker, please feel free to raise your hands or type in the chat. Before the interactive session, a humble request to all participants that kindly fill out the Google form, share in the chat box to receive your participation certificate. Your feedback will also help us in organizing future session better. Okay. Is there anyone, any question in the chat box? Okay, so here is a question from my side to you, both of you, that how do you see the role of emerging geospatial technology and also the civil engineering practices in enhancing disaster preparedness at the grassroots level? To the Gupinath sir and also the Ronit sir.
Okay, if you want, I can respond to it.
Okay. Okay, sir.
Yeah. So see, the geoinformatics systems play a very important role in
Yes.
identifying what kind of risk is there. Okay, so like what I was presenting on the cascading risk, compounding risk, systemic risk, these all, I think GIS becomes the tool to analyze this risk and present it to people, because it's just not about analyzing it, we also have to present it. And without that, it's very difficult for even the decision makers to understand. And at the community level, I think what possibly is missing is you can make presentations on your, like, you can tell them that, okay, you are at risk, you have this, you can see this maps that we have created, beautiful maps out of the remote sensing data that you have analyzed and other data you have analyzed. The problem is, on paper doesn't change the risk perception of people on ground. So I think there lies the major problem on how do we bridge this gap. Okay, how do we bring more different technologies and integrate it with where GIS becomes the foundation layer, but then then we need to also look into other technologies to take it further to the community. So I think this gap is still not yet bridged, or people are still trying to bridge possibly this gap. So I think there would be a lot of work needed in this area in future.
Okay, I have a question to you, sir, Ronit sir, that what advice would you give to young researchers like us who are working on disaster risk reductions in Himalayas and riverine context?
Okay. See, yeah, when you talk about researcher, I am also young, because as a researcher, you are always young, you are always learning. So,
Absolutely,
and
sir.
I think in the Indian Himalayas, the kind of length and breadth of it is so big that it's very difficult to identify various issues which are lying there. But I think what my suggestion would be is to kind of look into the interconnectedness of the issues in the Himalayas. I know it is quite difficult, but I think attempts should be made, more interdisciplinary attempts should be made to understand this kind of interconnectedness across disciplines, because what we still have possibly I would say academic approach in most of our work towards especially disaster risk assessments and other things, is our researchers, is we try to limit ourselves to our own expertise, and we work within our own network who are possibly people with the same expertise. But the moment we try to work across various disciplines, we just get possibly a bit worried that, okay, how will we try to bring in, like, say for example, social scientists, natural scientists need to work together. It's very difficult to make both the disciplines understand each other. But I think that's where the fun lies, and that's where, unless you make them work together, you won't be able to address the risk in its totality. So I think what my suggestion is to open yourself to have more interdisciplinary team and interdisciplinary researchers, and looking into issues which possibly you won't be able to address, but at least you can flag and bring in more people into it.
Absolutely, sir. Thank you, sir. Here is a question from Abdullah. Uh, you can ask the question, unmute your. Have you any question? Okay. Okay, as we approach the end of this meaningful webinar, I take this moment to express my heartfelt gratitude to Dr. Roy Chaudhary, Dr. Bhandari, and Dr. Chatterjee for their time, knowledge, and visions. To all attendants and colleagues for joining us and engaging with the important issues. At SAIARD, we strongly believe that resilience mountain system are key to climate justice and sustainable development. Thank you once again. Stay safe, stay aware, and keep contributing to a greener and more resilient future. Thank you, sir. Thank you all.
Thank you so
Thank
much.
you. Thank you. Thank you.